Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at the structure of the atom chemquest. Before we can learn about the structure of the atom, we do need to learn how to read the periodic table. So that's what I've shown you right here. I've taken this square of carbon and I just made it bigger so that everyone can easily see what's on the inside, and it makes it easier to label. So we can start in the top left corner. The number in the top left corner is the atomic number. Then you work your way down and you come to the capital big letter C. That will be the element's symbol. Right below the element symbol, you find the name of the element. And then below the name of the element, you find the mass number, or the average atomic mass. Be familiar with both terms. You'll hear me use it both ways. The unit that we use for the mass number is grams per mole. So guys, I will help you with questions 1A, 2A, and 3A. I can't really scroll down too much because then we can't really look at the periodic table. So if you look at 1A, it tells you that the symbol is W. So we come over here, look at the periodic table for the symbol W. You find that it is right here. 1A is asking us for the name. So remember guys, the name is right below the symbol. So we look right below the symbol and you see that the name is tungsten. So then that's what you see me wrote. I wrote tungsten for 1A. Next, you can do 2A. 2A is asking us for the atomic number. Remember guys, the atomic number is in the top left corner. So it's still for the element W, the symbol W, so all we do is look at the top left corner. The top left corner, it says 74. So then that is the atomic number 74. And then lastly, question 3 is asking about the average atomic mass for the following elements. Again, the first one is W. So this time guys, the average atomic mass is found under the name. So that's what we do right here, is we look underneath the name and you see the mass is 183.85. And then don't forget guys, include the unit that I gave you, grams per mole. So now do the same thing that I did for 1A, 2A, and 3A, and just do it for 1, 2, and 3, B, and C. Yeah. So then the next section, we are going to get into the structure of the atom. So it is important to know that you have 3 subatomic particles. That's what we call protons, electrons, and neutrons. Protons are always positively charged. I will abbreviate protons with a P and a little plus sign. And then down below in the pictures, protons will be denoted with a circle that's not colored in. Next, the second subatomic particle is electrons. Electrons always have a negative charge, and I will abbreviate them E with a little negative sign. Down below, electrons are represented by a little circle that's colored in. The last subatomic particle is a neutron. Neutrons have no charge. They are neutral. Make sure you guys write down the symbol. The symbol is just going to be a little N. We don't put a positive or minus in the corner because it has no charge. And then lastly, down below, neutrons are represented by a circle with an X through them. So, you guys are going to have to use these first 3 pictures. So these are 3 different forms of hydrogen. We'll talk about the 3 different forms in a little bit. But for now, questions 4, 5, and 6, you need to compare the pictures and determine how many protons, neutrons, and electrons are in each of the following versions of hydrogen. So remember guys, protons are a little circle with nothing in it. So you can look at the picture. How many protons are in 1,1 hydrogen? Protons, a little circle. How many protons are in 2,1 hydrogen? Again, how many protons are in 3,1 hydrogen? And you can go down the line and do that for protons, electrons, and neutrons. Questions 4, 5, and 6. Next, we move on to question 7. Question 7, we are comparing the structural characteristics of all hydrogen atoms. So later we're going to talk a little bit about the difference between atoms and ions. So that word atoms will be important later. So you already compared the protons, electrons, and the neutrons in questions 4, 5, and 6. What did you find out? What do all of the atoms have in common? What's the same? What doesn't change? Next guys, question 8 is asking you to do a similar thing, except this time you are going to look at the different atoms of carbon that we have. Because this center, this nucleus is a little jumbled together. Down below, I told you guys how many protons and neutrons are in the nucleus. That way there won't be any confusion. Everyone should be able to count up the electrons, no problem. Remember guys, the electrons are the colored in dots. So, what do you notice about all of the structural characteristics that all the carbon atoms have in common? Is it the same as the hydrogen atoms? Next, we move on to question 9. So to answer question 9, we need to use this little notation thing that they gave us. So we can compare it to what we see here, 12,6 carbon. So guys, right these letters right here, they tell us what each of these numbers mean. So the number in the top is A is the mass number. So that's what we see, mass number. Then we can look and see where Z is. Z is the atomic number, so we know that this right below it is the atomic number. And then lastly, this is the symbol. So compare. So question 9, we want to figure out what the mass number tells us. So if we were to compare the mass number, what do you notice about the mass number and the number of protons and neutrons? Next, question 10 is asking us to do the same thing, except this time we're looking at the atomic number. We need to determine what does the atomic number tell us. So we can look right here. So we look at the atomic number. The atomic number is the bottom. What do you notice about the atomic number? What is the atomic number equal to? Then question 11. Question 11, we need to determine what an isotope is. So if we continue through the notes section, it tells us that all of the examples of carbon and all the examples of hydrogen that we've been looking at, they are indeed isotopes. So throughout this page, you have been comparing the structural characteristics between them. So when you're thinking about your definition and you're defining your term isotope, what do you guys notice about the mass number and the atomic number? What stays the same, what's different, and why is it different? What you do in number 11 will help you with number 12. So number 12, how does one isotope of carbon differ from the other isotopes of carbon? So use this to help you. What's the only difference? Why is this number increasing? Next, we're going to continue to look at some subatomic particles. Just this time, now we're going to take a look at some ions. So this part can get a little tricky, so make sure you pay attention. Make sure you guys circle and write down your questions if you get stuck. I am going to be looking for questions and making sure that you guys have questions if you're trying to get credit for the chemquests. So, question 13. Question 13, we need to figure out what is structurally different between an atom and an ion. So this is the only difference. And like always, we are going to compare the protons, the electrons, and the neutrons. As you guys are starting to see, this packet is all about the protons, neutrons, and electrons, the subatomic particles. So we already know. So again, guys, I labeled it. I didn't draw them all in because it gets messy. But just so everyone knows that the nucleus has 9 protons and 9 neutrons each. When you compare the atom of fluorine to the ion of fluorine, the number of protons and the number of neutrons don't change. So the only thing left to compare is the electrons. If you were to count up these electrons, you would notice that the atom has 9 electrons and the ion has 10. So the only difference between an atom and an ion is the number of electrons. This next part, we need to determine what the mass of an electron is in atomic mass units. So the mass that it gave us is the mass in atomic mass units. We know that the only difference between the atom and the ion is 1 electron. So think about it. What could we do with these two masses if the only difference is 1 electron? What function would you use to solve it? I guess I have to show you that to be answer 15. So we take the two masses, 18.9985, and we subtract it from 18.9980. The reason why that works is because the only difference is 1 electron. So when you subtract the two masses, you're finding the difference, what's left over. And the thing that's left over is only 1 electron. So when you do this math out, you get 0.0005 AMU. So question 15. Question 15 tells us that most of the mass of an atom is it located in the nucleus or outside the nucleus? How do we know? So we have to use this mass of the electron to help us. So we know that the mass of 1 electron is 0.005. Wait, I missed the 0.005 AMU. We know in this atom that there are 9 electrons. So to find the mass of all of the electrons, we can multiply by 9. When you multiply that by 9, you find that the mass is 0.0045 AMU. So now you have to compare the mass of the, remember this is the mass of the electrons, compared to the mass of the atom, which is 18.9980. Whoops, can't see that. Sorry guys. So we multiplied by 9 to get 0.0045 AMU for the mass of the electron. We know that the mass of the atom is 18.9980. So we compare. All of the mass comes from the protons, neutrons, and electrons. So if this is the only mass that comes from the electron, that means most of the mass comes from the protons and the neutrons, which is located in the nucleus. So remember guys, most of the mass is in the nucleus because this mass of the electron is so tiny. So we call that, oops, my hair was bad, we call that negligible. So what that means is the mass of the electron doesn't matter because of how small it is. Next is question 16. So question 16 is asking you about the charge in the upper corner of fluorine. So that was comparing the -1 to here with nothing's written. When nothing's written, it's because the charge is 0. So when nothing's written, that's what you can assume. So when you're looking down here at the magnesium example, you can assume that this magnesium has a charge of 0. So why is it -1 and not +1? When you're answering this question, you need to compare the protons and the electrons. So you guys know that protons are positive and electrons are negative. So compare the protons to the electrons. Why do you think there's a -1 charge? Question 17. So question 17, so this is where I told you guys the word atom would come back. So the reason why atom is important is because if it's not an ion, then it must be an atom. So if we were to look over here at our couple examples of atoms, in every case, I like to use, so we can use the hydrogen. So you have 1 electron in each examples of the hydrogen, and then you have 1 proton. Remember guys, the protons are white. So every single atom will have a neutral charge, and that is because the protons and the electrons equal each other. Because of that, you have in this case, when you have 1 and 1, you have a +1 charge from the proton compared to a -1 charge of the electron, which cancels out to 0. So use what I just said to help you answer 17. Why is the charge on every atom 0? Question 18. So this is how you determine the charge of an ion. So that gets back to what we talked about 16, what we talked about 17. Remember guys, you need to compare the protons to the electrons. Remember guys, protons are +1, electrons are -1. So use what we just talked about, use your knowledge of the periodic table, and try and answer 19 and 20. Remember guys, 19 and 20 will be a little difficult. I want to see how you guys handle it. Remember, if you have a question, please circle it and write down your question. You will get credit if you write down your question. If it's blank, you will not. I hope everyone has a good day. So like always, I'll end with a joke. I just gotta find where I wrote it down. So what kind of music do planets like? They like Neptunes. I hope everyone has a great day. Bye.